All right, ladies and gentlemen, we're going to be talking about groups on the periodic table. And you have a blank periodic table that kind of looks like this. The only difference is yours probably doesn't have the horizontal lines that are going across. We are going to label these groups together. So let's get going. So basically, the groups are also known as families. Okay, so you have to know both names. Groups or families are found on the periodic table. Each of these groups have similar chemical properties. Basically, that means they're going to react the same. And we've kind of talked about those valence electrons early. That's what they have in common. Every group has the same number of valence electrons. So this group here, they have one. This group here, most of them have 8, except for this one. This one has 2 valence electrons. So each group or family have the same type of reactivity in common. All right, so let's go ahead and talk about the first group on the periodic table. It is group 1, the group to the very, very far left. They are the alkali metals. And it's important to note that hydrogen is not considered a member because it is a non-metal, but it does have 1 valence electron. And this is the most reactive group on the periodic table. So let's go ahead and label this group on your periodic table. The one on the far left, you're going to write alkali metals. And remember, this is the most reactive group. The next group we have, these are our alkaline earth metals. Alkaline earth metals. So on our periodic table, what I would like for you to put is just alkaline metals. The next group are your transition metals. Remember, these are the ones I told you guys early on that you would not have to draw Bohr models for these. So this is our middle section, the transition metals. So on this section, you'll write transition metals. Those are your transition metals. Our next group is the boron group. It is group 13. This says group 3. It's really group 13. So that's this group here that looks yellow. This is the boron group. Next we have group 14. This is the carbon family or the carbon group. So we have our carbon group. And as we're going across from left to right, the reactivity of these groups is decreasing. So the most reactive groups are on our left, and as we move toward the right, they increasingly become less reactive. Next we have group 15. They are our nitrogen family or nitrogen group, and they're going to have 5 valence electrons. So on your periodic table, you would write nitrogen group. Next, we have group 16. They have 6 valence electrons in their outer shell. And again, they're becoming less and less reactive at this point. So again, this is our oxygen group. And as I'm writing, make sure you are writing yours on there. Our oxygen group. Almost to the end, we have group 17. They have 7 valence electrons in their outer shell, and these are nonmetals, and they are reactive still, and most likely they're going to bond with elements from group 1 because it's every element's goal to have a full outer shell. And so a full outer shell for most elements, except for elements that only have 1 electron cloud, they want 8. So again, group 17, those are our halogens. I wrote it there for you. And lastly, we have group 18. These are our noble gases. They're all nonmetals. They have full outer shells, so they're not reactive, which means they don't want to bond with any other element. They tend not to be ones that like to bond. So again, these are our noble gases. And the noble gases are going to be the happiest group on the periodic table because they have that full outer shell. So to recap, group 1, this is our most reactive group because they only have one valence electron. Group 18, they're not reactive. And anything between these groups here, your reactivity increases. And those are your groups. That looks horrible. I apologize, but that says increases.